Hello, we're going to move on from equations, solving equations and doing a lot of stuff with those, to moving on to graphing, solving linear inequalities with one variable x. We'll solve them in much the same way that we solve equations. As we see here, it's very, very similar. There are two main exceptions. The first is if you multiply or divide both sides of an inequality by a negative number, you will need to reverse the inequality symbol. The one exception there, you multiply or divide both sides by a negative, you reverse the inequality symbol. So if you had a less than, you would switch to a greater than. If you had less than or equal to, you would switch to greater than or equal to. The other thing is we must graph the solution on a number line. Every point in the shaded area actually represents a solution. So we're not just going to have a single number that's a possible solution to the inequality. We will have more than one represented by where we shade on the number line. We'll get right into a couple of examples here. Hopefully you're able to see how similar these are. Our first one, x plus 5 is greater than or equal to 3. Still, the inverse of adding 5 is still subtracting 5, which we will do from both sides. We end up with x on the left side just like we would if it was an equation, greater than or equal to negative 2. 3 minus 5 is negative 2. So you see this is a one-step inequality, much like a one-step equation, but now we have to graph it on our number line. All I require of you is the 0 in the center point, and then we have to go to negative 2, which is right here. So now we have our negative 2. Greater than or equal to means negative 2 can be a solution. So that means a solid circle goes at negative 2. Now if I test the point 0 here, I substitute it in for x, I get 0 is greater than or equal to negative 2. That is true. So that means 0 has to be part of our solutions, so we would shade towards 0 there. The other way to think about it is the x values get greater as you go right. Next example. I have negative 2 is greater than x minus 4. From here, I will need to add 4 to both sides, just as if it was an equation. Negative 2 plus 4 is 2. That ends up being greater than x. The reason I chose this example is it's very important to say the variable first and go through our check. Because a lot of times we'll see the inequality symbol here point to the right, and it'll want us to shade to the right. Not always the case. Here's my 0. Here's my 2. So let's start at 2. X is less than 2, so that means it can't be 2, so we put an open circle there. Now, we test the point 0. I get 2 is greater than 0. That's true. So that means I have to shade towards 0, which is going back this direction. Say the variable first. X is less than 2. The values get lesser as you go left. Couple of examples here with multiplication and division. I have 1/2 times x is greater than 3. To get rid of the 1/2, I multiply both sides of the inequality by 2. Those cancel out. I get x is greater than 6. From there, I have my 0, and then I have 6 out here. Again, x is greater than 6. That means it can't be 6. So I use an open circle, and I shade right. Remember, 0 greater than 6, that's false. So I would have to shade away from 0 in that case. 3x is less than or equal to 9. The inverse of multiplying by 3 is dividing by 3. I get x is less than or equal to 3. Graph it. I have 0 and 3. Again, x is less than or equal to 3, so I have a solid circle because it can be 3. Let's test the point 0. I get 0 is less than or equal to 3. That's true. So that means 0 has to be a solution to our inequality, so we shade towards it. Now we have 0, -1, -2. All the numbers over here are solutions, not just 3, not just 0, anything to the left of 3. Now, just a slight change between these examples and the last two. We have a negative. We have -1/2. I need to make that +1. So I have to multiply this side by -2 and this side by -2. Now, this is one of those exceptions. When x is -2, or when we multiply both sides of the inequality by a negative, we have to reverse the inequality symbol. So this greater than, it'll drop down and become less than. I had to switch it. Those cancel out on the left, and I'm left with x is less than -6. So from here, we go to graph this. I go to -6. It does not equal -6, so it's open, and I go to the left. X is less than -6. -3x is less than or equal to 9. The inverse of multiplying by -3 is dividing by -3. So as soon as I divide by -3, I have to switch my inequality symbol. It becomes greater than or equal to. These still cancel. I get x is greater than or equal to -3. And I graph. 0. -3. -3 is again a solution, so it's a solid. X is greater than or equal to. We shade to the right. And our last two examples. Multiple steps. Just like we get into multiple step equations, we solve them the same way. The inverse of subtracting 5 is adding 5. So I get 2x is less than 12. I don't have x by itself yet, so I need to do one more step. The inverse of multiplying by 2 is dividing by 2. Cancels, cancels. X is less than 12 divided by 2 gives me 6. You don't have to graph that one. We've graphed a bunch. Same process for graphing there. We'll jump over to this inequality on the right. We can start this a multitude of ways. Doesn't really matter. I'm looking here. I'm going to subtract 4x from both sides. Here, 2x minus 4x is -2x minus 4 greater than or equal to -1. I have to add 4 to both sides. The inverse of subtracting 4 is adding 4. I get -2x is greater than or equal to 3. Again, x isn't by itself yet. I have to divide both sides by -2. I get x divided by a negative. I have to switch. Less than or equal to negative 3/2 is my final answer for that problem. That's pretty much it. We'll clear up a couple things, do some more practice in class. Have a great weekend. We'll see you on Monday.